Here's how to draw position versus time graphs in physics. So a lot of times you'll be given some sort of word problem, such as this one, where a dog is on a rocket accelerating towards the moon. 4 seconds after taking off, the rocket engines run out of fuel. It then takes another 2 seconds for the dog to reach a maximum height of 25 meters before the dog deploys a parachute to fall back down to the earth at a constant speed for 5 seconds. Draw and label a position versus time graph. Now I know this looks like a lot of information, but really all we have to do is break it down into specific time points. So the first thing I'm going to do is draw my position versus time graph, which is going to be the height, y, versus the time, t. The first critical time point is when the dog is on the ground at t equals 0. The next critical time point is going to be 4 seconds later when the dog is somewhere up in the air and the rocket engines run out of fuel. The third critical time point is going to be 2 seconds later when the dog has reached a maximum height of 25 meters. And the final time point will be 5 seconds later when the dog has safely made it back down to the ground. Now all we have to do is connect the time points. There are 3 ways you can connect these time points. You can either draw a straight line between them, you can draw a concave up curve, which looks like a happy face, or you can draw a concave down curve, which looks like a sad face. The trick to knowing which connecting line to use is to look at what the acceleration is. If the acceleration is positive, you'll use a concave up curve. If the acceleration is negative, you'll use a concave down curve. And if there's no acceleration, you're just going to use a straight line. Now, since the dog is on a rocket that's accelerating up, this means it has positive acceleration. Because of this, we're going to use the concave up curve to connect our points between t equals 0 and t equals 4 seconds. Now let's connect the next 2 time points from when the rocket engines have stopped working when the dog has reached a maximum height of 25 meters. Again, we have 3 options for how we can connect these 2 time points. We can either draw a straight line, a concave up curve, or a concave down curve. Again, all we need to do is consider what the acceleration is. Since this dog no longer has the force of the rocket engines accelerating it up, but it's still in the air, the dog is in what we call a state of free fall. And any object that's in free fall is only going to have an acceleration due to gravity, which is a negative 9.8 meters per second squared. So since the acceleration is negative, we're going to use the concave down curve. The final step is to connect the last 2 time points, from when the dog is at its maximum height to when it reaches the ground. Again, we have 3 options. We can draw a straight line, we can draw a concave up curve, happy face, or we can draw a concave down curve, sad face. Since in the word problem it states that the dog falls back down to the ground at a constant speed, this means the acceleration is 0. And since the acceleration is 0, we're going to use the straight line to connect these last 2 time points. And there you have it. That's how to draw position versus time graphs in physics. In the next lesson, we'll go over how to draw the velocity versus time graph and the acceleration versus time graph.